Chapter 4 will conclude with Lesson 4.8. We're going to come back to how we started Chapter 4 when we snuck in Lesson 3.7, where they first introduced functions. Now, because we've also learned about graphing linear equations and solving linear equations, we can bring in functions and relations. So, first of all, we just need to be able to identify a function. So, we need to decide when we see a relationship, is that relation a function or not? And if it is, we need to be able to identify the domain and the range. So in identifying functions, you learn that for every input, there corresponds exactly, I want to make sure you see this part, so 1 second here. For each or every input, there corresponds exactly one output. That makes it the case of a linear function that's defined by the rule y equals mx plus b, or the slope-intercept rule. However, there are rules that associate more than one output with an input, where the input corresponds to the outputs. A rule of this type, where an input can have more than one output, is referred to as a relation. A relation is defined to be any set of ordered pairs. So, first of all, we need to identify functions. So they've given us two different ones here. You'll see that we have an input-output chart here. And we see if the input's 1, the output will be 2. If the input's 2, the output will be 4. Input's 3, the output also is 4. And if the input is 4, the output will be 5. So this relation is a function because it matches the rules of function. Each input has one output. Now if we look at letter B, input 1 can either be the output 5 or can be the output 7. 2 is an output 7. 3 is the output 9. 4 is also the output 9. This is an example of a relation. And the reason that this one is a relation is because of the input 1 here. Input 1 ends up resulting in two different outputs. That makes it not a function, and we can only call that a relation. Now, there's some kind of neat ways to be able to find out on a graph if something is a function or a relation, and it is called the vertical line test. So you will have, and you actually have this tool right at the end of your arm. You can use your hand and make it into a vertical line, and you can put that over the graph and see instead of the red dotted line. So the first graph here shows a line. Now it's not just a simple linear equation like we're used to that goes this way. This one actually has an angle in it, and we can work on, we can use just the graph there to tell if that's a function. Let me get my other part of my line out there. So here is the linear, I'll get on my red pen. Here is a vertical line. That's why we call it a vertical line test. And then this is pretty neat. I can do this on the magic of Mimeo. I can select that line, and then I can move that line. So when I move my vertical line, at no point, doesn't look as straight anymore, does that vertical line cross 2 points at the same time. Now if I check this next graph, again with the vertical line, this one is also a function because at no point is that vertical line crossing 2 points at the same time. So your x axis, which is your input, is resulting in a different output, your y-axis, each time. That's why the vertical line test is working. If I can get my vertical line again here. Select my vertical line, there we go. And let's go on to the next graph. When I move to this graph, you can see I'm crossing 2 points at the same time. And I do that throughout this curve here. That makes this not a function. This graph is not a function. Let's just move it over to here a minute, and I'll take the selection off of it, because when I would be labeling this particular graph, here I have an x term. We'll say that's a -2. And so I went to the left 2, and we'll say I went down 2 as well. So we have a -2, -2. Now if I look at the point right here, we also have an x of -2. But that -2 also has the y-axis as 2. So we have the same input here. Sorry, trying to change colors, having some difficulty. We have the same input, but with two separate outputs, a -2 and a 2. That makes it not a function, and you can see that clearly on our vertical line test. So on my last vertical line test, I'll need a new vertical line now that I put those points on that one. I can go ahead and we'll see if I can do this one a little closer to that line. There's my vertical line, because mine can move, unlike the picture in the book. And I can move this vertical line right where it is right now. It passes and crosses there. Let's move it over a little here and then not select it. I have, there's a y, and here's a third y. So that makes it not a function. That's how the vertical line test works. So using function notation, which is what we started in lesson 3.7. When a function is defined by an equation, it is convenient to give the function a name. In making a table of values for the equation y equals 3x plus 2, you apply the rule by multiplying by 3 and add 2 to transform an input of x into an output of y. By giving the rule the name f, or function, you have shorthand notation for applying this rule to different numbers and variables. The fact that this rule transforms the input 1 into the output 5 can be written as the function 1 equals 5. In general, the symbol f with the parentheses around the x replaces y. This is very important. Make sure you add that to your notes. The symbol f apostrophe x replaces y and is read as the value of f at x, or simply as f of x. It does not mean f times x. F parentheses x is called function notation. All right, Kayla, I am